In hot and humid climate, it is challenging for energy efficiently maintain human thermal comfort at acceptable level. Improper placements of windows cause excessive exposure to sunlight, increases indoor temperature that leads to human discomfort. However, the fundamental problem with solely relying on active lighting system increases heat gain that causes discomfort for daily use. Hence, energy efficiency in office buildings often face the similar phenomenon where the higher the amount of sunlight penetrates into the building, the lower the human thermal comfort. Diamond Building is a shining example of using daylight as energy efficiency strategy. It was built as a third government energy efficient building that serves as a role model for all office buildings in Malaysia. The art of green architecture combined with the science of energy conservation is showcased in the 4,928 square meters and iconic 8-story office building in Putrajaya. The Energy Commission's Diamond Building was named the most energy-efficient building at the ASEAN Energy Awards, representing a 65% energy reduction compared to a typical office building in Malaysia. Besides, Diamond Building is the first office building in Malaysia to obtain the Green Building Index Platinum rating and the Island State's Green Mark Platinum rating. Climate and the solar path help shape the building's diamond form. This inverted diamond configuration successfully reduces building footprint and increases roof surface for solar panels installation. The form also increases available ground space for strategic landscaping to reduce heat island effect in urban area. Diamond building is oriented in accordance with the solar path, minimizing the areas impacted by direct sunlight, results with a total of 41% of solar impact reduced. In the structure diagram, it shows the orientation of diamond building allows north-south facades to be fully shaded, hence it maximizes the solar efficiency. Tree surrounding building perimeter prevents direct sunlight into the building. Landscape diffuses sunlight and mitigates heat load into the building, ultimately reduces cooling load which then saves energy consumption. Diamond Building utilized facade daylighting as an energy efficiency strategy. Daylight is reflected off the mirror light shelf and windowsills and cast onto the ceiling, deflecting it deep into the room till 5 meters from the facade and 2 additional meters from the corridor spaces. This design along with the fixed blinds that helps prevent glare. Low E glazing used in Diamond Building's facade is specially treated with coating on the surface that improve 25% performance of double glazed glass. Diagrams showing the effect of low E glazing in the facade of most visible light, UV rays and solar heat are rejected by the facade while most warmth are retained in the interior spaces to achieve thermal comfort for users. Solar studies showed that 25-degree tilting facades would provide self-shading on the facades. East-west tilting facade helped to reduce 41% of solar impact, while north-south facade is the same as the tilt of the sun path. Hence, sunlight never hit north-south facade directly. The Diamond Building is designed to be at least 50% daylit, without glare, and with minimal heat entry. The clear dome forms the central atrium and designed for the optimization of daylight. The central atrium alone provides 50% of natural light needed to illuminate the building. Daylight availability decreases deeper into the atrium. For the upper floors, windows are replaced with white walls to reflect light deeper down the atrium. The side of the atrium is lined with tenable reflective panels on levels 4 and 5 to allow deflection of light into the lower floors, where daylight levels are the lowest. Tenable automated glazing blind system consists of automated blind form a canopy over the atrium and ensures that daylighting filtering into the building is kept at consistent and adequate levels throughout the day. Furthermore, the blinds automatically shut when there is excessive sunlight in order to save energy consumption. An automated roller blind controls lighting in the atrium. The automated atrium glazing roller blinds consist of 24 individual blinds that can form 6 configurations help prevent direct sun while still illuminating the space. The blinds allow 30% of the light through to ensure daylighting for the offices facing the atrium even when the atrium blinds are fully engaged. Energy efficiency lighting such as T5 fluorescent tube with electronic ballast and LED lights are used throughout the building. 1-year measurements of installed office lighting have a consumption of only 0.9 watt-meter square, showing high reliance on daylighting. Daylight responsive lighting control is utilized to maximize daylighting. Integration with daylight sensors enable the artificial lighting to be switched off when daylight is adequate, resulting in energy savings. The use of daylight helps to further reduce the total lighting energy from 340 to 231 MWh per year, which represents an additional 32% reduction from the base building. Integration with the daylight sensors enabled the artificial lighting to be switched off when daylight is adequate, results in energy savings. Individual workstations are also equipped with task lights to further allow occupants to control the lighting. Occupancy sensors are installed where lighting is zoned so it can be limited to areas needing it. The total lighting energy is reduced substantially from 522 to 340 megawatt-hour, up to 35% of savings. For the Diamond Building, renewable energy is harvested through photovoltaics. The panels have a total installed capacity of 71.4 kilowatt peak, estimated to cover 10% of the building's energy needs. The panels have generated a monthly average of 8,300 kilowatt per hour and 100,000 kilowatt per hour annually, which provides cost savings on electricity charges. In conclusion, Diamond Building has implemented many design strategies such as dome lighting, innovative atrium, photovoltaic panels, slanting facade, light shelves, and low E-glass to achieve energy efficiency. The Diamond Building represents a new approach toward climate-responsive building design in Malaysia. Energy savings is 4 times better than typical office buildings, demonstrates the environmental and financial benefits of utilizing daylight as energy efficiency strategies. The Diamond Building is a shining example of energy efficiency, taking the lead in developing and implementing solutions for environmental sustainability and showcase the best practices in environmental solutions.